Okay, good morning, everyone on the West Coast, afternoon on the East Coast. Thanks for joining. Today we have Mary Thomas giving a presentation, an introduction to running Jupyter notebooks on Comet. Mary has a PhD in computational science, and she currently works in the Data-Enabled Scientific Computing Division, where she's leading education outreach and training on HPC systems. And she's got some good experience that she's going to be sharing with us today. Before we begin, I want to show this code of conduct slide. Exceed emphasizes the importance of proper conduct during these online webinars. Everybody's usually on their best behavior, but if there are any issues that you feel the need to report, there's an anonymous reporting form linked below. And with that, let's go ahead and get started. Take it away, Mary.
Okay, thanks everybody for joining us. I'm clicking on share screen. Host disabled screen sharing. Jeff, can you turn that on for me? Can you hear me, Jeff?
Yes, I just made you a
Okay.
co-host.
Okay.
Hopefully that will solve it.
Yeah. Okay. So let me just up here. Okay, so you guys can see the Zoom. All right, let's see what happens when I put this into. All right, can you guys see that? Okay,
yes.
so, all right. Okay, well, thanks for coming. The talk we're going to give today, that's just the abstract, is about, of all interesting things in the world, our concern about security on the HPC systems, starting with Jupyter notebooks and Jupyter services and other kinds of web-based services. We became concerned about them last summer. And so today, I put in this warning because there's been this recent spur of hacking from who knows who, cryptocurrency miners. I put in some links here. But it started in Europe and it has migrated to the US. So we're being extra vigilant here at SDSC and ask you guys to be vigilant too. So it's very relevant to just what we were worried about with the Jupyter notebooks that people are enjoying, and we want you guys to be using them, but there are some flaws and we're working on solutions to make them easier for people to use. So my goal for the talk today is to keep it very simple and very applied and give you some examples, and we've got repos that you can get code from and examples to look at. So if you have any suspicion that you might have been hacked, please get in touch with consulting or me or Scott Sakai, our security expert, and let us know if you think there's anything funny or different with your account. With that, I'll get started. For new people, this is sort of a beginner entry level webinar. I'll just do a brief overview of Comet, and there's a reason is so that we can address some features of HPC systems that are relevant for picking the right way to host a Jupyter notebook or launch one. And so a quick overview of notebooks. What are they, in case you don't know? What do they look like? How can they work? The difference between Jupyter notebooks on your laptop and on a supercomputer, and then the security concerns that we've identified, and then our solutions for addressing them. And there's some software requirements, and then some different ways of running notebooks. I'll review those, our categories, and then the ones that we have judged them to be acceptable, and then other ones we just prefer that you didn't do. And then I'll talk about a new service that we've been working on for the last year called the reverse proxy service, where you don't have to worry about tunneling and what kind of connection you've got. So I'll talk about that today, and it goes into beta testing today. And then hopefully we're lucky and have a live demo. So the key goal, though, is to learn how to run Jupyter Notebooks securely, so you'll be a little more worried. There's tons of links. What I've got here is where this webinar is going to be located when I'm done. We upload the material, and then eventually Jeff will digitize this into an interactive webinar. And then we have two companion repos. One is the actual notebook examples that we're supporting and that work on Comet, and you can download those. If you don't have any, you can work with whatever notebooks you want. And then more webinar information. This is a new site that we put up, and we're learning about Read the Docs. So you may find typos, let me know. And then if you want to know about other training events, we're building out Expanse, and you can go to our education and training page to find out what's coming up next. Feel free to contact me if you have ideas for what you'd like to learn about, and maybe we can incorporate those into our next year. Okay, so you need an account. If you don't, get one. Trial accounts. If you're trying to remember how to do things or you've only done Windows, there's a couple of basic skills tutorials you can look at on our repo. And the Comet user guide is always handy. Okay, so with that, we'll get moving. So basically, to log on, you guys all know you use SSH. Comet is comet.sdsc.edu. You can get on there from Linux and Mac using the built-in terminal. It's very good, and it's got a good SSH app. Windows now has the Windows 10 terminal app, and it's very good as well. Older systems would need to use PuTTY and Cygwin, and you can access Comet with passwordless login. And this is a totally excellent tutorial on how to set that up in case you'd like to do it. I have 5, 6, 7, 8 terminals open at a time, and passwordless login helps me with lots of tasks. So over here on the right is a reminder for those of you who need it, that this is the basic architecture of an HPC system. They're different than just the laptop on your desktop. They tend to have multiple login nodes. So when you log on to Comet, you might see you're on node 22 or node 1 or node 3. And then there's always some hardware in the middle of the connection between you and the nodes that you want to run your applications on. Lots of switches. This is a very simplified diagram. But the main lesson is it's SSH between your client and the login nodes. So that is what has a big effect on the security of your Jupyter Notebook, and we'll talk about that. Comet is a large system. It's not as large as 300,000 cores, but it's designed for a particular category of users that fall into what's called the long tail of science. A few years ago, some folks realized that most of the jobs that are run, there's a large number, not most, a large number of jobs that don't require several 100,000 cores, but there's a lot of them and they need a few thousand. And so Comet's built for that. We're in a second phase of the project where we're adding, we added on more hardware. And the current machine has about 2.76 petaflops. And someday, if you're in the area, come see our system. It's pretty fun to look at. Lots of hardware and hot air. So when you're working on Comet, you have access to about 2,000 nodes, 48,000 cores, CPU, now 288 GPUs, a lot of storage. We have some large memory nodes, 128 gigabytes, and then each rack has about 72 nodes. So there are file systems on Comet, and I put this in here. You can see all this in my Comet 101, but it's really important to recognize that we have several different file systems, and when you launch a Jupyter Notebook, it affects that where you launch it from affects where you'll be able to find your notebooks. So if you have your notebooks over on your Scratch project directory, but you launch your notebook from home, you can't get to those notebooks. So you have to really think through where you want to launch your notebooks. That's the biggest gotcha. And then of course, if you're doing any computational work, you need to do that over on your project directory, and also if you have a lot of large files that you need to be moving around. So you can go over and launch your notebooks from there, but you need to think about it if you're using a batch script or if you're just doing it from an interactive mode. That's the main reason I have that there. A little preview that coming soon, Expanse is our new machine, and it's a very interesting computing system with standard what we call our scalable compute units. They have GPU and CPUs, and then a large data system that's high performance storage to all the nodes. And then some integrated remote cyber infrastructure with, including cloud computing and remote resources, open science grid, and composable systems will be built on these resources. And it's scheduled to start up in August for early adopters and October for production. Okay, so if you log on to Comet, you're going to see a new message that the operations people have asked me to bring up, which is when you log on, the Comet login nodes are not to be used for running processing tasks. It's a very busy system, and thousands of people log on to these nodes. And so if you start running processes, you bring down the system availability for everybody. And so if sysadmins see that you're running some big application or a notebook, they'll just kill the job. So I know that's frustrating, but you can compile if it's not going to take a lot of energy, a lot of computational time. Okay, so make sure you don't do that. Although I will show you examples today of very simple notebooks because it's convenient and it's easier to show. But in general, running notebooks on the login node are discouraged. If you want to use some of our notebook examples, we're building up a repository of notebook examples, and I've got the link here. And these are going to be notebooks that, to the best of our ability, we guarantee that they're going to work. They're like Hello World, and notebooks that you can get and make sure that your system and your environment's working correctly, and we'll talk about that. So feel free to download and clone the repositories and get, and it's an aggregation of work done by lots of people at SVSC and elsewhere. Okay, so there's certain software requirements, and this gets a little messy, and it's an NP, incomplete graph of how many different ways you can install software and run a notebook on any HPC system. So what I tried to put together today are really, I should call it best practices on Comet. So my focus is running notebooks on Comet, doing things using the Comet infrastructure, and it may or may not work on another system like NERSC or Blue Waters. For example, if you go to Blue Waters, they have a completely different mechanism for launching notebooks, starting with the requirement that you have a password that's installed on your local disk. So every system is different. So that's why I thought putting together a set of steps that are supposed to always work for you if your environment is correct and the system's running normally. So again, you can go to this tutorial guidebook that we've put up, and there's a repeat and some more deeper instructions on prerequisites. So there's a difference between HPC systems and your laptop. So this is a really pretty view of running Anaconda, which is a Jupyter an application that runs Jupyter applications and other apps. And it's really easy. You click on the icon, up comes this window. You click on this launch button, and up will come a Jupyter Lab application. And it's colorful and easy to work with. So on this one, I launched the notebook. And this is, no, actually, I launched Jupyter Lab. Jupyter Lab is an aggregate of notebooks and other key components that you would need for doing work on computational work or working on HPC. Jupyter Lab has a file navigation, file browser, and you can open multiple tabs. And here I'm just showing a simple little trapezoid, but I can also go to this little icon here, and I can open up a terminal window. I'll show you an example later. And the advantage of notebooks, if you haven't worked with them, the reason they're so popular is you can do Python, Java is supported. I believe other languages like C and C++ are supported. R is supported, and I think MATLAB. A lot of different languages and environments are supported inside. But it has this feature of you put your code in to these blocks, they're cells, and you can execute each one of these cells one at a time. You can break them up if you need to debug. And so you're interacting, you're inside your code and interacting with it live. You can program, you can run it, you can reset and start over. And the power is that interactivity of with your application. In general, people are using notebooks for visualizing and interacting with data. So it's really great for machine learning. Software required for running Anaconda Conda notebooks on HPC systems. It's not so easy as go to Anaconda, download it. You have to do things at the Unix level, but if you're working on HPC systems, you can kind of, you're used to it, I think. So it's nice to have a customized virtual environment for running notebooks, because if you didn't notice it, I had to import different libraries, NumPy, Matplotlib, and the more complicated your code, the more you'll want to import them. And although we do have Singularity containers that Marty Candace builds that work for notebooks and other applications, they're fixed. You can't change them. And so if you really want to have control, you would benefit by biting the bullet and just starting to install Anaconda, install Conda, to install your packages and start building up your local environment. And so there's a command called Conda that is used like pip, that's like homebrew. It's the way you install the libraries and packages into your Python environment. And we have some hints and instructions on how to do that in our guide. Optionally, you can use Singularity containers, and I think I have a link in the guide to those. And they will work for, let's say, vanilla generic Jupyter notebooks. There's TensorFlow ones, and Marty has a whole library of ones. The benefit of using our Singularity containers is they're always going to be working, and if there's a problem, we'll fix them. The disadvantage, though, is you can't modify it very easily. And so if you find as your application gets more sophisticated, you need more packages, then you can just start building your own environment. Okay, so Conda is the package installer. It works, like I said, like pip, easy install, and it's very easy once you to install. Once you can get it if you install Anaconda. If you don't want to use up the space of Anaconda, and you're not going to need all the other features of Anaconda, just install the Conda package management application. It's created for Python programs, and it works really well. Here's a great cheat sheet to figure out, to run Conda. So you can use Conda to create something called a virtual environment. And a virtual environment, when you launch the virtual environment, you will know that the certain packages it's like modules on HPC systems. You would load a module for the Intel environment or the CUDA environment. With Conda, you can create all the packages and libraries you need to run your Jupyter notebooks, for example. So, and there's different commands that you can see what you've built. You can start them, stop them, and delete them. And again, caveat, be aware of where you launch your notebook. The login nodes and the nodes that run batch scripts, they have access to the home directory, but the compute nodes don't necessarily. It depends on the system and how they've implemented it, and where you launch your notebook, like I said, will affect what uh, file system you can browse, and you might not be able to access your notebook. Okay, so simple overview of notebooks. Why do we use them? They're fun, they're colorful, they're dynamic. You can get inside your data and inside your code and interact with it. And they're fast to work with, they're fast to learn. And so go to jupyter.org to learn about them. There's a bazillion places where you can download examples and get started. Again, the ones I have are not the ultimate set. They're just ones that I'm going to guarantee for you that they're always going to work. And if we upgrade our operating system, we'll go through and make sure our notebooks run. So it's just a quality of service for you guys. So Jupyter Notebook is a community open source, and their goal is to make it very easy for the community to interact and do scientific research and have collaborative workflows, and it supports 100 programming languages. So that tells you that these guys are pretty serious. I wish I could do a poll and see hands go up on how many people have used it, but so Jupyter Notebooks are web-based, and this is really important to realize. When you fire up a notebook, it appears in a web browser. And when you fire up a notebook on the way we're doing it on Comet, it will appear as a web service, and you'll load that web service URL into your local browser. So they've really done an amazing job with the interface and the tools that you can use that's through a web browser. So that's very interesting and exciting. And this is just a little architecture diagram showing the Jupyter Notebooks running somewhere. You're sitting on your desktop, running your web browser, and you connect to the Jupyter service somewhere running. It could be on your laptop. There's a lot of communication that has to go on between these services. So Jupyter Lab, like I showed you in the image, it integrates the Jupyter Notebook and other tools that people say that they need to get their computational work done. And so it does add the Windows terminal. It has editors. It has a lot of features, and I think they keep adding to it. Jupyter Lab and Jupyter Notebook both come with Anaconda, or you can install them separately with Conda. So make sure that you do install them. So here's a picture of firing up Anaconda on my desktop where I launched Jupyter Lab, and you can see here I put in a terminal and I logged on to Comet. So here I am developing code. I can log on to Comet, I can transfer code, I can do a lot with this interface. And then here I'm launching just a notebook. If I click on one of these notebooks here, and you can tell it's a notebook because it ends with .ipynb, up will come one of these windows and it will show you the code. And then you can also execute it. So just making sure I'm good on time. Okay, one weird thing for somebody who's not a Unixy person is when you fire this local Anaconda Navigator on your laptop or system, there will be a Unix terminal window that pops up, and you can monitor what's going on with the web service. Jupyter Hub is a server that you would put onto a system where this is where multiple users can have access to the Jupyter Hub, and they can run Jupyter Labs and they can run Jupyter Notebooks. And there's some security caveats in this system, which I'll talk about in a moment. But these Jupyter Notebook and Jupyter Lab, those are single user. Jupyter Hub hosts the Jupyter software services for multiple users. It's like a portal. A Jupyter Hub is like a portal. Okay, so the security, here's the big thing. If you think about the way you launch notebooks, there's a lot of different ways. So I wanted to show you, in our opinion and our experience, this little graph goes from red, which is not safe, to blue, green and blue, which are safer. And the SSH, the typical one is you could log on, you could run the notebook on the login node and connect to a client browser. but it's not secure, it's not encrypted, because the connection, and I'll show you a diagram, the connection between your browser and the service being hosted on Comet, for example, is HTTP. It is not encrypted. So you have to realize from it, and you can do it, but a lot of people are doing it, and their accounts are vulnerable to being hacked. And in light of what's happening with HPC systems today, it's really time for everybody to change passwords and tighten down your code. So there's this area where we're just SSH. You can even tunnel SSH tunnel out onto the login node, but if you don't do it correctly, you're still going to be possibly insecure, and also we won't like it, because if you run it on the login node, that's against our policy.
Jupyter Hub. Sorry, can I jump in? Is it possible for you to get that button bar to disappear?
I don't.
This slide.
How do I do that?
Well, I'm not.
Okay, let me try and just move it.
And dragging might help.
That's as far as it'll let me drag it.
That's an improvement.
Okay, sorry guys. I thought I was the only one seeing it. Thanks for pointing that out, Jeff. Not a problem. And hopefully if you have questions, feel free to ask them. We've got Jeff and Marty, who are part of the team for notebooks, and can answer your questions. I can't see the chat, so I really don't know. All right, so the next level up, we have Jupyter Hub, could be running. Typically, Jupyter Hub is installed on the login node, like other portal services, but what Scott Sakai has learned is, and is concerned about, is that it runs as root. Some of it, the operations run as root, which exposes the entire file system. So we're not running any service like that on any login nodes, and we're exploring ways to host Jupyter Hub and Open on Demand, for example. The team is working on hosting that on a virtual machine, and then we manage the connections through SSH. So that's a big concern, and I'm not sure that people are aware of it. So that's one of the things we're trying to get that message out, is it may not be as safe as people think. Although if you go to a Jupyter Hub, what you see is an HTTPS secure connection, and behind it, it's mostly secure because it sees the internal network, but it's not decoupled from your file systems. So you get a little bit safer when you're SSH tunneling correctly, and you're running the service on a interactive node or a compute node, and the messaging is all over through the SSH tunnel, and the HTTP connection is then secure and encrypted. One of the disadvantages is you can't always control the port number, and so you have to figure out ways to do that, and our reverse proxy service helps control that. So real secure is have Jupyter Hub, for example, running on a virtual machine, so that it's not as able to have an impact on the local disk. And the reverse proxy service, which I'll talk about, that launches a request to the batch system to get you a compute node, or to get you a compute node, and builds a special token and launches a service for you that is HTTPS, and you don't have to deal with tunneling and all of that. All right, so let me go back on here. All right, so the key vulnerability, like I said, is the notebooks provide access to HPC file systems. So here's an example where I launched a notebook on Comet, and it's HTTP, it's not secure, and I'm able to see my file, my directory. So if you've been doing your notebooks this way, please stop, because what you are is you're exposing that unsecure HTTP connection. And so we're developing some policies that are right now like a guideline. Some are actual explicit policies, but portals, Jupyter Hub, other services can't be mounted directly to disk, the login disk. Whoops, sorry about that. And then if you launch applications like a Jupyter Notebook, the jobs will be killed. if the sysadmin people see them. And then no applications can run on the login nodes. That's been there for a while anyhow, but you can bet they'll start enforcing it. And then a recommendation is that you use secure connections when you choose these insecure connections. You could get hacked. So there's different methods for running notebooks, and on Comet, the most common ones that we've seen are scenarios and then where you can run them. The scenarios are you connect the notebook over HTTP, and at the end of the day, you're sitting on a machine and you're generating a notebook or a Jupyter Lab server, and you're going to put a URL into your web browser. So when I say connection to the notebook, that's what I'm talking about. So the least secure one is over HTTP. Then you can make it a little more secure with SSH tunneling. It's just inconvenient. And then you can get a direct HTTP connection with the reverse proxy service. And we're beta testing that now. And then coming soon is a script that Marty has been developing called Galileo, and you run the script on your local system, and it does all the making connections to the remote machine and launching a notebook for you and returning a secure HTTPS connection for you. And I'm not sure about the timeline for that. The notebooks can be run on the login node, but we don't want you to. Interactive nodes, we'd love for you to use the interactive nodes, and then compute nodes. And we have examples, and I'll go over them really quickly today, but there's examples in the tutorial guide that give you explicit guidance on how to do it. The compute nodes and then GPU nodes. We have examples in that in our repository. Not all methods are secure. I'm hoping you're getting the message. It depends on your method for connecting and the level of security. So we're worried about, is it HTTP or HTTPS? And are we using just SSH or are we tunneling? Again, this is sort of a repeat. So what does it look like, right? So we're not confused. This is my laptop or my local workstation. And when I do SSH, I use port 22 typically, although you can change that. And I connect to the SSH server on a remote machine, which is typically port 22, although that can be changed. But the point is that once this connection is made, the communication along this connection is encrypted at a pretty high bit rate, so it's pretty secure. And so that's great, but what do I do when I go onto Comet? I go onto the login node, or maybe I'm really good and I get my interactive node, or I'm on my my compute node that I got through a batch queue request. And then I type, Jupyter launch notebook, and up comes the insecure, because there's no HTTPS. I launch a Jupyter service running on port 888, and it's HTTP. And I make a connection and I type that URL in my web browser. This communication here is not secure. It's not inside this secure channel here. So that's why you go to tunneling. So if you don't tunnel and connect your laptop to this server here, this service port here, then your communication is open. So it's easy to, it's straightforward to do, and you just need to get in the habit. So it's called port forwarding. And we have a discussion of it in our tutorial. And also, this is a lot of this information is from the Ubuntu community page down here at the bottom. So port forwarding is when you connect an SSH connection between two ports that you know about. The typical SSH is between port 22 and 22. And the connections are encrypted, and it's used all in a lot of places. There's three types: local port, remote port, dynamic. We'll focus in on the local port because that's what we use. That's what I'm suggesting you use for notebook service, and it's pretty common. So how does this look compared to that other diagram? You still have to log on to Comet through an SSH server so you can start launching your notebook. And then what you do is on Comet, you launch the notebook and take and keep track of certain pieces of information like the port. Let's say you launch, you start it and you get a port number. Then what you do is you have a connection between your local laptop through SSH, and you can pick any port number you want except 22. Pick one that's not in use and make a connection to port 8888. Now this is a secure encrypted SSH connection back to your Jupyter Notebook or your Jupyter Lab server. And that's really all you have to do. The reason it's sometimes challenging is you can't make this tunneling connection before you get that port number, and you don't know what that port number is. And if you try to predict the port number, then it's often going to fail because ports get used and dropped and start, used and dropped all the time. And I had it happen over at another system where we thought we had the port number and then it would disappear. So one of the things in the reverse proxy server system is that the port number is as guaranteed as Scott could figure out how to make it. So this is what you're trying to achieve, is you're going to end up with two terminals. One terminal is the one that you started with, where you're tracking and watching and monitoring, did I get my interactive node or do I have my batch compute node? And the other one is going to be a terminal dedicated to the communication with this server. And when you get that URL and you put that URL into your web browser, all that communication will be going along this secure channel. Okay, so this is a simple example of running it. A Jupyter Note. I'm on Comet. I'm just going to run Jupyter Notebook, and I get my connection, and there's no port forwarding. Boy, I am port forwarding, and so I ran it. I know what my ports are, and even though this says not secure, the communication's going through that secure SSH channel. So it's that's why I wanted to go through this picture. It still says HTTP, but that's because this is HTTP, but the data itself is encrypted. So I had to log on here and then log on, make a connection as a second terminal connection. Okay, so the reverse proxy service. We're doing good on time. I want to make sure that James McDougall, our UCSD student, has written a lot of this scripting and codes. And if the system's up and running, then hopefully we can do a live demo. So I'll try and move along on this so we have time for questions. So what's a reverse proxy? It takes requests from the internet and processes them and then forwards them to servers. Some work gets done and then it returns data back. But the internet, whoever's out here, can't get directly to that machine. It's pretty common. There's a lot of them in use around. So we sat down a while back and started talking about how can we change the way notebooks are run and avoid SSH tunneling because that's inconvenient. And it's extra work for people who just want to run their notebooks. And also we were looking out ahead to interactive computing, where the nodes are meant for interactivity, and cloud computing, where you might be able to go out and launch a quick instance and interact with your resources via your notebook. So we really wanted to find a way to simplify and streamline running notebooks. And so the way it works is we have this firewall and you log on and you run a script called Start Notebook, and the script will go and talk to a reverse proxy service, get some information like a token and arrange for a port number, and build a URL and return that to you, and you can see what that URL is going to be. And then while you're waiting for the batch system or the interactive node to be assigned to you, you have to wait and hope, nobody can get rid of that pain yet on HPC systems. But once you get your interactive node or your compute node, then you'll be sitting over here with your web browser waiting for your HTTPS connection to a port that's assigned to you with your special token to be active. And at that point, you're running your notebooks on Comet, and it's a secure communication. So this is a prototype system. We're in beta, like I said. So we're really interested in feedback and learning how to make it robust and learn how does this scale and the pros and cons of using this, and are there ways we can get rid of some more of the pain points associated with trying to launch notebooks. It's available now, and the goal is to minimize software changes for the users. So we think it's simple. It requires no tunneling, and it's secure. And so to use it, you can go look at our training guide. You log on, you clone the repo, so you've got the startup scripts, and you check your software environment to make sure it's working. And with that, again, oh yes, there's people on the team, Scott Sakai, Marty, myself, James McDougall, who have been working on it, and we're ready to go. Okay, so give it a try. If you have trouble with the system, contact help, or feel free to send me feedback, complaints, likes, dislikes to myself or Marty or Scott. Okay, with that, I'm going to stop sharing. And is James online?
Yeah, I'm here. Let me.
Are you ready to? So are we ready to try a live demo?
Well, I mean, I haven't given one ever, but I think I can do that real quick.
Well, there's always.
I mostly just want to make sure I don't show anything on my screen that I don't want to see.
Right, and so while James is cleaning up and getting his screen ready, are there any questions that I can answer? So Marty is suggesting that you use Miniconda to save space in your home directory. Yeah, Anaconda can be quite large. And Liz Garcia, you want a link to the resources? Yeah, I'll do it right now.
Mary, I think Jeff already posted some links there.
Oh, did he? Okay.
And I think even a copy to your slides that has all the links too.
Yeah, there's links all through my slides, but they're not available exactly when I move the bar. Done.
All right, I think I'm ready to start, if it's all right.
Yeah, go ahead.
Right. Oh, I guess I can't screen share. It says the host has disabled screen share.
Yeah, Jeff's gonna have to make you a host, I think.
Yeah, co-host. You will be powerful.
Oh my.
Right. I'm trying to take back hosting privileges from Mary, and I don't seem to be able to do that. Is that something you can give up, Mary?
I don't know. Let me look. There's a link to our tutorial. I could log out and log back in.
No, don't do that.
No. Okay. I don't see how to do that. I see lots of control things.
Click on the participant list, and then I think you can right-click and make one of them a host or something.
Okay. Yeah, but which one? James, are you in under your name or?
I'm under Jeff, honestly, I think, because.
Yeah, I think he's the third one down.
Yeah, my picture should be obvious.
Yeah.
I can rename myself, I guess.
Okay, you are the host.
All right, cool. Yeah, so I'm just gonna first show you some of the GitHub repos we have. This is we have a reverse proxy repo, which is gonna have all the reverse proxy code and tutorial. We have Notebooks 101. You've already seen the links for that. So that's just github.com Notebooks 101. And we also have this website. This is the main, I guess, tutorial documentation website. So I'm going to be using this. This is a good one to use to follow all of our tutorials. So I'm just going to go to reverse proxy service.
Yeah, I just posted that.
Yeah, I believe this link
Oh,
is
yeah,
somewhere. Everyone has it. So yeah, we're just going to follow these steps. You're going to clone this repo. You'll see I'm already logged into Comet over here. So make sure you're logged into Comet. Then you're going to clone this repository. Okay.
James, can you make your font a little bigger in the Unix window?
Oh, okay.
That's good, thank you.
Cool. So I have the repository stored in reverse proxy. So now I'm in the reverse proxy directory. I'm going to list everything in my directory. The easiest way, the default way, is just going to be to run, I guess we can use the bash command, or it's just an executable, however you run your executables. So we're just going to run it. It gives us this output. So here's a link. You're going to want to copy and paste that. But let me just read through this info real quick. So there's a lot of defaults that are in this script. So default queue, what's it called? Partition is compute. There's compute and debug. You can actually specify a batch script. Now the batch script is what actually starts the Jupyter Notebook, even though the script is maybe misleadingly called start notebook. Start notebook basically starts the reverse proxy connection and submits a batch script. And so you can see the default batch script is going to be this. And we have a few example batch scripts inside the repository. Singularity one is not working yet. That support should be added soon. But Batch Notebook and Jupyter Lab should be sufficient for most things. Okay, so I'm going to paste the link now. And there we are. We have our Jupyter Notebook. And if you know how Jupyter Notebooks work at this point, that's probably enough. It's just a regular Jupyter Notebook. If you don't know how Jupyter Notebooks work, this is I don't know. I like this is like the Google TensorFlow as an object detection example. So I don't know. I like this example because it's pretty easy. But seriously, it is far too many things in one repo though. So don't do this. Oh, there it is. And here we have notebook. I'm just going to show you that notebooks actually work. So now you can see if the notebook is executing cells one at a time. Now, okay, with this tutorial specifically, I've already installed a lot of things, which I'm not going to go through right now with Anaconda. So you may have to install stuff with Anaconda. For example, you're going to have to install TensorFlow with Anaconda here. So yeah, I don't know if this was mentioned, but the reverse proxy relies on you using Anaconda right now. The Singularity example is ideal for the future, obviously. We'd like to be able to use containers, but for now, you're going to have to know how to use Anaconda, be pretty familiar with that to install a lot of the packages you want. But the nice thing about the service is if you forget to install a package, you can install it while the notebook is running, and then it'll still be available in your notebook. So if I forgot to install NumPy just now, I can just go over here, install NumPy, and then I could rerun that cell and it would work. And so you don't have to cancel your job and waste 30 minutes of compute time or whatever doing that. And oh look, we can detect a dog. That's nice. Yeah, I mean, that's about it. So yeah, just following this tutorial here if you need a refresher. There's a lot of different arguments. So here's an example. I guess I could show, how much longer should I take, Mary? I can show an example with Jupyter Lab.
I think a couple more minutes and then we'll see about questions.
Sure. So yeah, there's a few different arguments you can give the script. I just showed you I don't really want to do that. Let me show you the example. So if you do the -d, you can start it in any directory you want. By default, it's going to be tilde or home directory. So maybe we try code models research so we don't have to click as many things next time. And of course, that's not visible now. And another thing you can do is you can specify the batch script, as I said earlier. So let's try Jupyter Lab maybe. And you can also specify the time with the time doesn't have an option. So if you just put the time at the end, it'll assume what the time is for you. So like, I don't know, 30 minutes. Default is minutes there. And so yeah, this would pop up a Jupyter Lab notebook and let me try to catch this before it gets submitted. There we are. So you can see actually we have to wait for the reverse proxy to do some work and for Comet obviously to accept our job. This screen is going to occur when I believe Comet has already accepted our job. Yeah, Comet accepted our job about 30 seconds ago, but the reverse proxy still needs to secure the connection in a sense, and still needs to do some work for the notebook can be run, but you know, that could take a couple minutes. You could furiously refresh the page if you want. That's usually what I would do. Yeah, I guess I could quickly check out. We could quickly check out this batch script. Let's check out batch notebook. Oh, what am I doing? So yeah, we have say don't edit below that line. These are the sbatch parameters. So if you're familiar with sbatch already, you know you should be able to edit these on your own. But obviously, we don't have any responsibility if you change the sbatch parameters and something breaks. If you want to see the output, for example, you could delete this line and you default partitions debug. So yeah, we just start a notebook here pretty much. Yeah, so that's an example batch script. So if you want to make your own batch script, you can just copy one of our examples, edit it, and try to use the -b argument to execute it. And here's Jupyter Lab. Nice. Yeah. Now I got a terminal here. I haven't done this very much. I don't know if I could submit another batch job from here. That would be trippy in the inception. Now I could just go into any of these, I guess. Oh, yeah, don't do that. Yeah, I mean, that's a quick example how to start up some notebooks. There will be more tutorials on the docs website soon. So yeah, anything I missed, Mary?
No, I think that's good. Thanks, James.
All right.
Appreciate it. You may stop sharing. Okay, I think that's it, unless people have other questions. Somebody asked, is reverse proxy very specific to Comet? Yes and no. So the way it's being designed is we are planning on making it so it will run on any system, HPC system. It's fairly generic at the moment. The main requirement would be where you would host the reverse proxy server, and it's looking like our next test would be to install an Apache server on a node, an independent node, and you want to make sure that the server is going to stay up and not crash on people. So we have to do some stress testing on that and see what we have to worry about. But the idea and Scott's intent is to make it available for people to download and install and host on their own. And I guess that's it. Jeff?
Great. Thanks very much, Mary. And thanks everyone for joining. We will be making a recording and the slides available soon after this webinar. Thanks very much, everyone. Have a great day.
Hey,
Thank you.
Hey, take care. Stay safe. See you soon.
Thanks.
Bye, everybody.